Lesson 2.5, Absolute Extrema and the Mean Value Theorem. Absolute maximum is the y value that's greater than any other y values of the entire function. It is an absolute, there's the highest point in the whole graph, period. Absolute minimum is a y value, it's the lowest or less than any others. A relative maximum or a relative minimum is the greatest y value in its area, and the relative minimum is the lowest y value in its area. So there might be other y values that are higher or lower far away from it, but in its local area, that's why it's a relative. Extreme points are those maximum values or minimum values, so the highest or the lowest. And then critical numbers. In calculus, we take the derivative and make it equal to 0, or where is the derivative undefined, and those are what are called critical numbers that we test to be able to find those maximums or minimums without having to go to Desmos. Alright, here we go. Here's the candidate test. First of all, find all the critical numbers of the function. That's the derivative equal to 0 and where the derivative is undefined. Find y values at each critical number and each endpoint of the interval. Choose the least and greatest y values and you are done. Absolute extrema can occur either at a critical number or at endpoints. Relative extrema only happen at critical numbers. We will not consider endpoint extrema to be relative extrema. Here we go. So first of all, looking off a graph, this will be super easy. What's the absolute maximum of this function? What's the greatest y value? And the answer is 4. At what x value does the function have an absolute maximum? That answer is -4. What is the absolute maximum point on the function? That would be 4, -4. Notice you have to say the word point to actually write it as a point. What's the absolute minimum of the function? Notice there's a low, there's a hole. That means it doesn't exist. We don't have an absolute minimum because the lowest value there is a hole. What x value does the function have a relative minimum? So where's there a low, right? So the x value there is -3. Where else do we have 1? Right here, a low. That's at +1. Anywhere else? A low. Oh, right here. I know, it's a little tricky. But in its area, this is a low point, even though it's not connected. It's like a point out of place, but it also acts as a minimum right there. So also at 2. So that's kind of a tricky one. At what x values does the function have a relative maximum? So the x values right here at -1. There's a relative maximum, and I think that's it. So there's a hole there that would create a maximum, but the hole means there's not one there. So only at -1. At number 7, find the global. That's another word for absolute extrema of this function on this interval. So let's go one step at a time how we would find that. So the first step is to plug in the end points. So we're going to plug the n values into the function and then solve it. So if I plug -1 in for x and solve it, the answer would be -7/3. If I plug +3 into the function, the answer is -9. So I'm just plugging it in for x and doing the work. Those are the answers. Now the calculus, I'm going to take the derivative. So 3 times 1/3, that's 1. Subtract 1 from the exponent. 2 times -2 is -4. Subtract 1 to the exponent. There's the derivative. So first of all, there's nothing that makes this undefined. Make it equal to 0. We're going to factor out an x and then solve it. So one answer is 0 and the other answer is 4. But if I look carefully at the domain restriction, I have to cross out 4 because it's not between -1 and 3. So the critical value that I'm going to find is 0. So if I plug 0 in, that's an easy answer. The answer is 0. So the global extrema would be the absolute maximum. So what's the greatest y value here? And it's 0. and the absolute minimum. What's the least, the lowest y value? And that's -9. In number 8, find the absolute maximum and absolute minimum, same as global, just a different word that means the same thing, for this function here. So, first of all, I'm going to plug in 0, and I'm going to plug in 5. So if I plug in 0, the absolute value of -2, plug in 5, take away 2, the absolute value of 3 is 3. So there's, to begin with, now the calculus. I can't take the derivative of absolute value. So when I look at that, what makes it, I'm really looking at where the derivative is undefined. So if I graph this at +2 right there, the derivative is undefined at a sharp corner. At what x value? So we're going to use +2 because the derivative is undefined there. In fact, there's nowhere where the derivative is equal to 0, but it's undefined here. So if I plug 2 in, you get the answer 0, and then you can have the absolute maximum, which is 3, and the absolute minimum, which is 0, based on these numbers. So the greatest number is 3, and the smallest number is 0, and it's done. Number 9, find the extrema, that another way of saying absolute max, absolute minimum on this interval. Step number 1, plug in -1. Just so you know, cube root of -1 is negative, but when you square it, it's going to become +1. So 3 times 1, and negative times the negative, this is 5. Plug in 3. So this, the cube root of 3, you can't, or the cube root of 9. So it's 3 times the cube root of 9 minus 6. So the cube root of 8, go to something you know, is 2. So 3 times 2 is 6. So 6 take away 6. So it's a little bit bigger than that because the cube root of 8, the cube root of 9 is a little bit larger. So this is a little bit larger than this. So if I was going to estimate it like whatever, it's a little bit bigger than 0 just to have an idea of that, estimating that number. We're now going to take the derivative. So 2/3 times 3, the 3's cross out, you're left with 2. Subtract 1 to the exponent, 2 take away 1, 2 take away 3. There's the exponent. The derivative of -2x is -2. So first of all, if I write this like this, you'll see where is the derivative undefined, what x value is a restriction, and that number is 0. So we need to plug in 0 here. That will give me the answer 0. And if I make it equal to 0 and solve it, you get the answer 1. The cube root of 1 is 1, and 2 divided by 1 is 2, so that satisfies it. +1 is on my list. 1 to any exponent is 1, so it's 3 take away 2. So now we can be at the spot where we only look and say, okay, what's the biggest number of all the numbers I came up with? There's 4 of them. So the absolute max is 5. And the absolute minimum, this is where it's important to know, to estimate that this is a positive number. This number is a little bit bigger than 6. That means 0 is the smallest number there. All right. Find the global maximum and minimum of this, I like trigonometry, from 0 to 2 pi. So first we plug in 0. So the value of sine at 0 is 0. The cosine at 0 is 1, so this is -1. If I plug in 2 pi, I get the same answer because 2 pi and 0 or at the same point on the unit circle. Now, if I take the derivative to sine, the derivative of sine is cosine. The derivative of cosine is negative sine, but it needs a little hook of 2. So I have 2 cosine x plus 2 sine 2x. I'm going to divide everything by 2. So I'm going to divide everything by 2. Oh, my camera went. Go. Don't know why my camera does this, but it does. Let's try again. Yay, it's working. So there's nothing that makes this undefined, but I need to solve this equation. So I need to know at what values they would be equal to each other. So at pi over 2, two times pi over 2 is just pi, and the value of pi is 0, and the value of cosine at pi over 2, that's also 0. So at 3 pi over 2, it's going to be the same thing. And then we're going to test those values out. Those are the ones that will satisfy the equation. So if I put those back here, at least at pi over 2 and 3 pi over 2, those are easy numbers to plug in. So the value of, so here, at pi over 2 cosine is, well here, pi over 2 for sine is 1. So 2 times 1 is 2. Cosine would be 0, but 2 times that gives me pi, because the 2's cross out. So the value of cosine at pi is negative 1 times the negative is plus 1. So that answer is 3. The value at 3 pi over 2. So sine at 3 pi over 2 is negative 1. So that's negative 2. Again, 3 pi over 2, the 2's cross out. 3 pi is in the same location as pi. So that's negative 1. And a negative times a negative is plus 1. So this answer is negative 1. And so the absolute max is 3. And the absolute minimum is negative 1. That's the lowest y value and the greatest y value. That was really tricky. All right, let's turn the page. The last part of the lesson is about the mean value theorem. So I use that acronym for it. Secant line means the same as AROC. A tangent line means the same as IROC. So if I want to know the average rate of change, I use 2 points and connect them. So right there, that's called a secant line. The mean value theorem says if this is continuous and differentiable in that interval, which it is, the average rate of change is equal to the instantaneous rate of change at least 1 point. So if I draw a line that's parallel, so derivative means slope. So here's a tangent line compared to a secant line. The slopes are equivalent. Now that could occur at more than 1 point, but it has to occur at least at 1 point, where the average rate of change is equal to the instantaneous rate of change if it's continuous and if it's differentiable. So here, if I connect A to B, that's called a secant line. That's the average rate of change. Then, is there a tangent that gives me the exact same slope? That would mean it's parallel. So do you notice that there are two moments where the tangent is parallel to the secant? So those are two moments where A rock equals I rock. Here, number 13, it is not differentiable, so this does not work. It has to be continuous and differentiable. That sharp corner means it's not differentiable. Same thing here, 14, it is not differentiable from A to B. There's a moment where it's not. It has to be differentiable and continuous, both. Number 15, again, A does not even exist. So from A to B, it does not apply. And if you look here from A to B, again, it's not continuous. So it must be continuous and differentiable. And then we can see what the MVT. This is really what it's saying. A rock equals I rock, at least at one point. And we're going to do that right now algebraically. Okay, for 17 to 19, it says draw the secant line between 2 and 5. So here's 2 and 5. There's the secant line. And then it says draw the tangent line to that, touching the graph. So if I was going to do a tangent line that's parallel to that, that's what it would look like. And then it says approximate where it occurs. So at what value does that occur? So it's about at 3, where the A rock and the I rock are equal to each other. If I look at number 18, from 2 to 5. So notice up to 2, we have a sharp corner, but from 2 to 5, it works. So we're only going to look from 2 to 5. It's continuous and differentiable. So from 2 to 5, so first of all, connect these points. That's the A rock, the secant. And then I'm going to find where's the tangent on that graph, where it would only touch the graph at one point, but is parallel. And then think, where does that occur? Those parallel things where it just touches at 1. So like pretty close to 2.8. The other one, what would you say, 4.8, 4.9, something like that. We're just estimating like where those things occur. Number 19, connect the 2. And then the parallel lines that are parallel to it. So there's 3 spots where you could do a parallel line and it just touches at one point. And that occurs like at 2.5, 6. This one, if I go down here, when does it occur? At like 3.7. Here, where does it occur? Go all the way down like at 4.8, 4.9, 4.7. But you can see there are 3 values where that's true. So that's looking at it conceptually or graphically. We're now going to look at it algebraically. This is A rock, and this is the derivative. So you have the derivative and that. This is the same as saying I rock equals A rock. And the key here is continuous and differentiable. If it's continuous and differentiable from A to B, then there has to be at least one moment where I rock equals A rock. And there could be more than one. Alright. So we're now going to look at the mean value theorem here. So step number 1. From 3 to 6. So first of all, at 0, it wouldn't work. But 0 is not in my interval. So this is continuous and it is differentiable from 3 to 6. So if I take the derivative here, this is 3 subtract 6 to the negative 1. So a negative times a negative is positive 6 to the negative 2. So if I write it this way, you can tell that the derivative is undefined also at 0, and that's it. So in this interval, it's fine. 0 is the bad number here. So there's the derivative. I also need to find the AROC, the average rate of change on that interval. So that's how I'll find it. Plug 6 in. 6 divided by 6, that's a nice number. So 3 subtract 1, that's 2. 3 is also a nice number. 6 divided by 3 is 2, and 3 take away 2 is 1. So this all simplifies to what? 1/3. So then we take the 1/3 and we make it equal to each other. And then that's what I'm going to solve. So I'll subtract 3. 1/3 subtract 3 is, get common denominators be easier, right? 3 and 3. So that's -8 over 3. There it is. I'm going to cross here. So it's -8x squared is equal to oh, wait a second. You know, I did wrong. And negative here. Well, the derivative is positive, right? Oh, I know what I did wrong. The derivative of 3. Let's try this again. So the derivative of 3 is 0. So when I take the derivative of 3, it's 0. So we're just left with negative times a negative. I'll do that over here. Positive 6. That's the derivative. The derivative of 3 is 0. So I made that mistake. And make it equal to 1/3 and then solve it. So this is 6 over x squared. So now when I solve this, it's x squared equals 18. And then square root. Now be careful. We're looking at an interval from 3 to 6. So the only answer is positive root 18. Negative root 18 is not in my interval. So find that which satisfies it, and you just found the answer, which is root 18. All right, a challenging lesson. We're going to do the assignment now together and keep learning. Mr. G Math, over and out.